Applications of Gauss's law. Planar symmetry. Electric field due to a charged infinite sheet. Consider an infinite plane sheet with surface charge density sigma. Symmetry indicates that the direction of electric field must be perpendicular to the plane. Consider a cylindrical Gaussian surface, symmetrical on both sides of the sheet with base area A and length L. Flux through the cylindrical Gaussian surface is the sum of flux through the curved surface and flux through the bases. Consider an area ds bar on the curved surface. Direction of the electric field is perpendicular to ds bar. Hence, flux E bar dot ds bar is 0. Therefore, flux through the entire curved surface is 0. From symmetry, the magnitude of electric field E must be equal at every point on each of the bases. Consider an area ds bar on one of the bases. As electric field is parallel to ds bar, flux through ds is equal to eds, and flux through one of the bases is equal to E into A. So, flux through the two bases is 2 times E into A. Hence, net flux through the Gaussian surface is equal to 2EA. From Gauss' law, this must be equal to the charge enclosed in the cylinder divided by epsilon naught. Charge contained in the cylinder is sigma into A. Hence, electric field is sigma by 2 epsilon naught. The electric field at a point does not depend on the distance of the point from the sheet. Hence, a very large sheet that is charged uniformly creates a uniform electric field perpendicular to it.